6.1, exponential growth and decay. First thing we're going to talk about is the general growth or decay formula. A equals P times the quantity of 1 plus or minus R to the T power. There's actually two formulas inside of here. One of them's plus, one of them's minus. Which one do you think growth goes with? Plus. Why? Because it's growing. Decay is going to be the minus. A stands for the final amount. P stands for the principal, original amount. R is your rate, and it has to be written as a decimal, not a percent. And T is time in years. This should look familiar. This formula here is also used for interest, for compound interest. The population of a city is 152,494. The population is decreasing at a rate of 1.5% per year. What will the population be in 10 years? What's happening in the problem? It's decaying. What's happening to the amount of people? It's decreasing. People aren't decaying. It's the number of people is decreasing. So the one thing you should know right off the bat, what should your answer look like? It should be less than that, 152,000. If you end up with a number bigger than 152,000, you have a problem. So we're going to use the formula. A equals P times quantity of 1. Which one am I going to use, the plus or the minus? Minus R to the T. We're trying to find the final amount, correct? What's the principal or the original amount? 152,494. 1 means 1. Minus. It's not 1.5. What does 1.5% mean as a decimal? How do I change a percent to a decimal? Move it over 2 places. So instead of 1.5, it becomes 0.015. Just because 1.5 is a decimal does not mean it's written as a decimal. How many years? 10. Everyone understand how I put all these numbers in? The trickiest piece, and this is where you're going to make your mistakes, it's right here. The rest of the, what's that? You always move it over twice, because percent is always out of what number? What's a perfect, percentage-wise? 100. So if I divided that 1.5 divided by 100, if you got 1.5 out of 100, you actually got 0.015. Right. Now, the rest is in the calculator. You got to be careful about typing in the calculator. 152,494, parenthesis, 1 minus. Now you don't have to put the 0 point, but you got to make sure it's 0.015, parenthesis. How do I get that 10? The caret and then the 10. Once you have that, all you hit is enter. What is the population? It is about 131,104. Now, I want you to think for a second. Why didn't I use a decimal? It's people. Why? You can't have a part of a person. Even a midget counts as a full person. And a giant doesn't count as 2. Regardless of the height, a person is a person. So that's why there can't be decimals. How I got 4? The 0.7 rounds it up. The rate at which caffeine is eliminated from the bloodstream of a child is about 25% per hour. So you drink that can of pop or that cup of coffee. After an hour, 25% of that caffeine is out of your bloodstream. A child drinks a cup of pop and the caffeine in their bloodstream reaches a peak level of 30 milligrams. Predict the amount to the nearest tenth of a milligram, the caffeine remaining after 1 and then 4 hours. This problem is a decay problem because the caffeine is being eliminated. You're not adding caffeine into the bloodstream. The caffeine is leaving your bloodstream. So it's a decay problem. I want to see if you can solve it for the 1 hour. I'm going to use the decay formula. A equals P times 1 minus R to the T. For the amount after 1 hour, what's the original amount of caffeine? 30. 1 minus, what's my decimal? 0.25. What's my time? 1 hour. So I just type this in. I'm going to type 30. 1 minus 0.25 to the first, which I don't even need to the first. After 1 hour, there are 22.5 milligrams left in your body. How do I do it for 4 hours? Just switch the Y to a 4 on the calculator. Second, enter. What do I have to do? Just change the 1 to a 4. Press enter. 9.4, it says to the nearest tenth, right? So 9.5 milligrams. So after 4 hours, you still have 9.5 milligrams left in your body. Let's see if we can find out when it's 0, when you have no caffeine left in your system. So let's go into the equation. Y equals. I'm going to type in 30. 1 minus 0.25, or you can just write 0.75 to the, what's changing every single problem? The hour, so I'm going to make to the x power. Now, I'm just going to make sure, second table set, second window. Yours should start at 0 and be delta 1, correct? Do second graph. If I do second graph, at 0, I have 30. At 1, 22.5. You see at your 4, you have the 9.49. I need to find out when y is 0, or close enough to 0. Yeah, that's close to 0 right about here. How many hours is that caffeine still technically in your system? About 28 hours. There's still a trace in your bloodstream. There's a trace of caffeine left. This is for a child. Your bloodstream pushes out stuff faster. As an adult, like when I drink my cup of coffee, it doesn't leave my bloodstream every 25%. It leaves my bloodstream at 15%. So let's see, if I change mine to 0.15, when does it 30 milligrams of caffeine leave my body? Wait till I get a double 0. 48 hours. So that same can of pop that you drank, it took you 28 hours for it to completely be out of your system. It takes me almost 2 days, actually more than 2 days for that caffeine to leave my system. That's just caffeine. Other stuff to stay in your body longer. A bacteria population grows rapidly and doubles every hour. If there's an initial population of 250 bacteria, how many bacteria are present after 3 hours? So this is going to be the growth. A equals P times 1 plus R to the T. We're trying to find out what A of 3 is. What's the original amount of bacteria? 250. 1 plus something to the third. All right. If you got a perfect on your test, what percent did you get? 100. Now, what would be double of that? 200. What's 200% as a decimal? 2, right? 2.00. So it has to be 1 plus, not 2, 1 plus 1. How did I get 1? It's 100% plus another 100%. I have doubled it. Inside, what's 1 plus 1? 2. I've doubled it. All right? A lot of you were putting 2 in here thinking you're doubling the rate. But this whole entire thing is telling you what's happening. 1 plus 1 is 2, which means I'm doubling it. So in the calculator, all I have to do is type 250 times, what's 1 plus 1? 2 to the third. You don't have to write 1 plus 1. If you can do the little math, just type it in. I was just letting you type it in as is. After 3 hours, how many bacteria are there? 2,000. In just 3 hours, 250 bacteria became 2,000. If I change this, second, enter. If I change this to a day, what do I have to put here? 24. One thousandth million. It's 4.2 billion. There's 4.2 billion bacteria. Now that's saying there's enough food for the bacteria to grow. What starts to happen after there's too much bacteria on something?
It goes old.
How can you really tell something goes mold? That's how do you think they figured out the expiration date? They just guess and say, yeah, this milk is good until this day.